Hello everyone, I am Sagar and today we are going to solve the problem, and the problem is height of binary tree. So let me explain this question with this test case. So in this case test case we have given a binary tree, binary and binary tree is like 1, 2, 3, and we have to find the height of binary tree. So the height of the binary tree is 2, 1 for this level and 2 for this level. For example, if we have binary tree like 1, 2, 3, 4, then for this binary tree, the height is going to be 3 because 1 for this, height 2 for this, and height 3 for this. So this is what we have to do. We have to find the height of binary tree. So let me tell you the approach. So let me erase it. So if we have binary tree like 1, 2, 3. So first of all, we will call to left. Int a will call our function for the left. Root left. Then we will call the same function for the right subtree. So let me try run this code for you. We are at root and our a is 0 and b is 0. Then we will call for left. We are at 2. Our a is 0 and b is 0. Then we will call to left again. Then here there is null only. Then we will return 0. Now here there is 0 in A, then we will call to right, then there is nothing in right, so this will return 0. So A is 0 and B is 0. We will take the maximum of both these two. So maximum of 0 and 0 is 0. Then we will include the current node, that is 2. So we will add 1 and then we will return. Then there is 1 in A. Then we'll call for the right, and there is 3 in right, 3, and for 3 A is 0, B is 0. Then 3 will call to its left, and there is nothing to left of 3, so this will return 0. Then there is 0 in A. Then 3 will call to its right, and there is nothing to right of 3, then it will again return 0. So there is 0 in A and 0 in B. So we'll take maximum of these two, that is 0, and we will add 1 to it and we will return. So for 1 got 1 from the left subtree and 1 got 1 from the right subtree. Then we will take the maximum of these two, that is 1, and we will add 1 to it. So answer is going to be 2. So this is what we have to do. Let me code this approach. I will make a helper function help, and here I will receive node. So base case will be if root is null, so we will return 0. If the root is 0, or you can say that null, then we will return 0. Then the second part, recursive call and some small calculation. So first of all, I will call for left, then I will call for right. I'm calling for left subtree, then right subtree. Then once I will get the height for left subtree and the height for right subtree, then I will take the maximum of 2, max of left subtree and right subtree, and I will add 1 for the current level, and I will return this. Now I will call this function return help, and I will pass root to this function. So let me run this code. Help. Mm, so the name is node, not root. So you can see that we're getting correct answer. So let me discuss the time complexity for this approach. The time complexity for this approach is going to be big of n, because we are iterating, or we are going to every node. So time complexity is big of n. If you talk about space complexity, so it is going to be height of tree. So I hope you know why this space complexity is height of tree. So this all for today's question. Thank you.